Hello everyone. Welcome to our Stats 2.5 tutorial demo problem for week 1. Let's dive right in. So the question that's been given to you, I'll read off, is to calculate the sample standard deviation of the following sample data using the definition, i.e. not the calculator statistics functions, of sample standard deviation. Report your answer using 2 decimal places. So as you probably know, there are some shortcuts that you can use on your calculator so that you can save some time and not have to write out a bunch of work. But in this particular question, like it says in the parentheses, we're asking that you don't use that because on a test you might be asked to actually show the work of doing this. And so we have our sample data here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. And we want to find the standard deviation for this sample. So the first thing we're going to need is a formula for standard deviation, which has been given to you and is this hideous looking thing here. So we have here that S, the sample standard deviation, is going to be equal to the square root of the sum of all the square differences divided by n minus 1. Now that sounds like a mouthful, and it is, but we can break this down into some smaller parts so that we make sure we don't miss any steps or mess up the answer. Now, we have this formula, and we see in it that we have an xi. Well, the xi is each element of the sample data. So x1 would be 10.2, x2 would be 10.3, and so on down to 12.9, which would be x11. Since we have 11 sample data points, that means that our n is equal to 11. We also need x bar, but we don't know what that is. So we need a formula for that, which you should also have been given. It's a much simpler formula when we want to find the mean x bar of data. All we do is add up all the data points and divide by n. In this case, which would be 11. So if we do that, we simply add them all up, divide by 11, and we see that our final answer for x bar is 12.3. Okay, so now we have n, x bar, we know our xi's, and so we have everything we need to solve the final problem. And there's many ways to do this. As long as you use your BEDMAS rules, then everything would work out fine. I'll show you the method that I use because I think it's simple, it's step-by-step. There are methods that will be faster, but this one should safely get you the right answer every single time. So what I do is I set up a little table. And so we see that we have xi, and the next column is xi minus x bar, and the third column is xi minus x bar squared. So we start by noticing that the first xi, x1, is 10.2, and so we fill out the table in the following way. Xi is 10.2. If we take 10.2 and subtract the mean, 12.3, we get negative 2.1. Then, if we square negative 2.1, we get 4.41. So that row is now done. The next thing we do is move on to the next data point, 10.3. For that, 10.3 minus 12.3 is negative 2, square it, and we get 4. Then we move on to the third data point. In this case, we have x3 is 9.8. 9.8 minus 12.3 is negative 2.5. We square that, and we get 6.25. We simply repeat this all the way through to the last data point, which would be x11. In this case, that is 12.9. So 12.9 minus 12.3 is 0.6. We square that, and we get 0.36. So now let's look at our formula again. What have we done this far? Well, if we look in the numerator of the formula, we see that we have each element of the xi minus x bar squared. That's our last column. And in the numerator, it says we need to sum these all up. So that's what we'll do. The sum of xi minus x bar squared is simply the sum of all of the elements in the column, the third column here. And once we calculate that, we find that it's 35.52. And so now, if you look in the upper right corner, we see that we have that entire numerator solved. We know that portion there is 35.52. Our next step is we want to divide by n minus 1. And don't get confused, because down at the bottom it says s squared, but that's just because we're not doing the square root part yet. So if we take our 35.52, which we got in the previous line, and we divide it by n minus 1, so we divide it by 10, we find that s squared, not s, but s squared is 3.552. And this is good to point out that this is actually the variance. So depending on different problems, we can measure the dispersion of the data with variance or with standard deviation. Sometimes one is more helpful, sometimes the other. And the only difference between the two is if you have variance and you want standard deviation, you just take the square root of it. If you have standard deviation and you want variance, you simply square it. So the final step is just to take the square root of 3.552, which turns out to be 1.88, and voila, we have our final answer. We kept the tutorial demo problem fairly straightforward this week. Things will ramp up quickly, so expect to watch the demos in the future because they will get more and more difficult. And that is everything we have for now. I will see you in tutorial this week.